Hi. I am Chris Hillman, CEO and lead developer for Parametric Systems, and this is Harnessing Artificial Intelligence for Software Creation. This is not about how the artificial intelligence operates. That would take too long. This is about the way it happened, because it was not planned, and it all started long ago. A short history is a good place to start. 1972, I was given a task and an NCR 315 computer and told to make it work. The School of Hard Knocks had begun. Primarily my career has been assemblers, COBOL, PL1, Visual Basic, IMS, KICS, etc. On mainframes and mini-computers, none of which involved formal training. Structured programming replaced unstructured string, and a variety of techniques such as data dictionaries were promoted, to try to bring some control into very disorganized computing. I am not sure if this has changed much, and there are still techniques being promoted to improve, or perhaps gain, control. Data dictionaries seemed to be a good idea, but they had one deficiency: they were just documentation. If they could be put to use, they would become important. So, a 45-year quest began. Through many projects and environments, I came to believe that if I could imagine a method, I could program it, which lead to many different projects, including this one. In 2010 a project was requested, that required open access to information from a database. Open access is access by anyone, at any time. No user registration, no passwords, and not negotiable. It was mandated in this international treaty, which governs the training and certification of seafarers. But open access does not mean uncontrolled access. It just means that control has to be different. Two methods were imagined and built. The first was a gateway structure, to control access to the main program. A gateway is access through an open web page, say a corporate site, where people who know can trigger a control, that transfers them to a secure site. Any access to that site, other than from the gateway, is ignored. This I mention in passing. The second was to quarantine the database from any direct internet access, which produces a structure, like this very schematic diagram, and this becomes important. Consider this to be an internet environment. Clients, servers, networks and so on. These are shown as a user program. There is also a database program which has one function, accessing or recording data on the database. This is only done when a user program sends a recognizable control. The database program operates, and then returns a result to the user program. There are two important points within this structure. First, the user program is the controlling program. The database program is just a slave. Second, this structure can operate as a client-server structure with the database being quarantined from the internet. The next thing was to learn to internet programming. The School of Hard Knocks hadn't given up on me. For the internet I decided to use VBNet for the server process, because I knew a lot about Visual Basic, HTML, and JavaScript, for the client process, since they were similar to languages previously used. I came across Webmatrix, an easy-to-use text editor, which introduced me to the Razor syntax, and I devised a program structure that was simple, and workable. Like this. 4 separate divisions. But all in one file. Razor syntax allows easy data transfer, from the server to the client. HTML sends data to VBNet, or to JavaScript, and can access JavaScript processing, allowing processing in the client terminal. So, this one program structure becomes a client-server, Internet program. Coding became very repetitive, and I started to imagine. What if there were loads of parameters, in a data dictionary, which could be inserted into the repetitive structures, in HTML, or used as controls on JavaScript processes, or used to automate data transfer, from HTML to VBNet. For example, this will move any date from the client screen into the VBNet server process. I stress any date. The code just has to be included, wherever a date occurs in a user program, and the dat_n parameter replaced by the name of the data and a number. Development then became analyzing existing code, and recording it, so that parameters could be inserted, and the code generated. There are over 600 of these code fragments, and the parameters are replaced by details from the data dictionary, using generator processes, that also structure the code into the user, or the database programs. The generators both rely on rule-based, narrow, artificial intelligence. User programs are specified as single-purpose, black box structures. This simplifies the user program logic, and makes the automated construction possible. It also makes the user programs very internet-friendly. Small programs load faster, and data is returned faster, if the size is kept small. This is the structure shown earlier. The database program is one monolith of compiled VB6. It is also generated, but by a different generator process, and has a completely different structure. It is derived from an artificial intelligence analysis of the database table specifications, and the information being transferred into, or out of, a user program. This is the database program that is quarantined from the Internet. In the largest of the test developments, the code fragments were used repetitively to produce over 170 user programs, containing over 250,000 lines of parameter-driven code, plus 335,000 lines of common, support, code, at an average rate of 1 program per person hour. So, I ask, can your information technology do that? I can with the assistance of artificial intelligence. Enigma is a complete integrated development environment. Now I want to show a short video, to give an impression of the simplicity of using this artificial intelligence. Enigma is Parametric Systems' automated application development suite. Enigma is not development with no code. Enigma is not development with low code. Enigma is an integrated development environment that generates 99% of an application. Enigma 2020 is a simplified user interface for Enigma. This video explains how to use Enigma 2020. This is the Enigma 2020 interface. It works by making many assumptions about a new application. The banner across the top allows access to the original Enigma, where any of these assumptions can be changed. We will not be looking at these in this video. The 2020 interface allows all of the content of an application to be recorded. The first thing is to identify the application. This is done by entering the application name. And confirming it using the accept control. This opens up the details that must be decided for the application. The short name is used for identifying the databases and libraries used to hold your application. It must be unique within the Enigma records. There will be 2 databases, one holds user tables, the other holds the data required by your application. There are 3 logs that Enigma can create to allow monitoring of the databases. The user actions log monitors the user database, and will record all changes to the user database content. This will be a very low volume, since the user database is changed rarely. The database actions log monitors the application database, and will record all changes to the content. It can monitor the database content in a snapshot implementation. The history log also monitors the application database if a history implementation is required. A history implementation records all the changes to the database records, so that there is a trace of what happened, and when it happened, to every application record. If a history log is requested, there must also be a database log requested. Select each log by clicking on the Y or N controls. Confirm the selections using the Save Application control. As the message says, all of the files, libraries and default programs will be created. This takes a few seconds, after which the program name field will be opened. But before starting to define a program, it is a good idea if there is some diagram showing the application and how the programs in it interact. This is my run chart for gathering the content required by the Motokana application. It shows the programs and the navigation between programs. The navigation looks quite complicated, but Enigma will make it easy to construct. We will not be looking at navigation in this video. It is covered in the user interface video. The blue shapes have already been coded. The next collection of programs to be done is vehicles, which starts with vehicle find. Enter the program name and use the accept control to open up the screen heading, and the program type selections. Enter a heading for the user interface, and then select the program type. There are 4 types available. Default specifies a program that will run before the application starts. It can be used for user identification, logon, etc. Internal frame specifies a program that will have a user interface displayed on top of the user interface of the preceding program in the navigation sequence. Menu choice specifies a program that will run when selected from the application menu. Subprogram specifies a program that will have a user interface that replaces of the user interface of the preceding program in the navigation sequence. These types do not have to be memorized. Enigma 2020 has a built-in help facility. Just double-click on any field where you want an explanation. Double-click again on the help text to clear the display. Use the Change Details control to blank out any errors. The Save Program control records the program and opens up the action field. In Enigma, the programs primarily operate by using a series of transactions to communicate with other units required by the application. These units can be the database holding the application data, the database holding the user tables, a program external to the application, or the application memory. In Enigma 2020, the transactions are specified by selecting an action. There are 11 alternatives and the help facility explains each of them. In this video they will be explained as they are used when specifying the vehicle programs. The vehicle find program uses a find action to allow the user to specify which vehicle they want to add, or change in the data database. The find action only has one part, which is the content needed to control the vehicle search program that follows in the navigation. Enter the name for the content, data and content field, and then use the content save control to save the name and access the data definition panel. This panel allows the specification of a large amount of the data control for the application. Most data in an Enigma developed application has 2 names. They can be the same or different. The content data name that has just been entered is the one used when specifying the visible part of an Enigma developed application. The database name will be used to identify this data in the invisible part, the application database. Having 2 names allows Enigma to separate information and data. Information can be defined as data with meaning, and the meaning comes from the context in which the value held in the data is sourced or displayed. So, Information is in the province of the user interfaces in the application. Data, on the other hand, is just a value held somewhere, usually in a database. So, there can be different information obtained from one data value, depending upon the context. For example, a teacher's name and a pupil's name. Each is different information, but both contain values obtained from the same data. Enter the database name for the data, and use the accept control to record that name, or use the search control to display a list of the previously specified database names, so that the names can be accurately connected. More of the data definition attributes, that need to be specified, will then be available. The selected attributes will define how Enigma will validate the data, when it is entered, and how Enigma will construct the HTML, when displaying or receiving the information. Stored size specifies the maximum size of the data in characters, that can be stored in the database. Any entered data value, longer than the stored size, will generate an error displayed to the user. Data type specifies the formatting applied to the data, and basic validation rules. There are 14 different selections, which are detailed in help. If you want to read all about them, then pause the video. When you start play again, the help will scroll down. Display size specifies the number of characters to be displayed on a user interface. It does not have to be the same as the stored size. For a drop-down selection list, only the abbreviated value for each alternative would be stored, but the expanded alternative would be displayed. Caption is a default field name displayed with the data. It can be altered when specifying the user interface. Caption size is the number of pixels used by the caption. It can be changed when specifying the user interface. If the space is too small to hold the caption, then the caption will split into 2 or more lines at the space character, closest to the end of the specified caption size. HTML input specifies the HTML format used for the data. There are 4 alternatives detailed in the help text. Initial value specifies a default value to be applied to the data, when creating the database table holding the data. Caption location specifies the default relationship of the caption to the data. It can be changed when specifying the user interface. Input status specifies how the user interface will display the data, and how it will record the data on the database. Use pause to read the help details. Selecting yes for data selected specifies that the content will display as a drop-down list, from which one value can be selected. 2 fields are available to specify the name of the list. One is mandatory, and the other is optional. These fields also specify the name of a radio button list, if that selection is made from the HTML input selections. The name entered will provide the name for the table in the application database, that will hold the alternatives for the drop-down, or radio button list. It will also be the program name prefixed by SEL for selection lists or OPT for radio button lists, when the program to maintain the drop-down list is created. Both selection and radio button lists are entered into the application menu, and the alternatives required in the list have to be entered, using the application. Generation of the menu entries, and the maintenance programs, is automatic. One selection or radio button list can be connected to more than one content data name. This is particularly useful for yes or no selections. User selection of a radio button can trigger a changed request to the database. Thus, a default request can be modified to a more specific request by changing the radio button. Select yes, in the data section process request, to cause this. The data description is a specification of what the data represents. The descriptions can be searched to find data that may supply the value required for the information. The tooltip will be shown to the user, if the cursor hovers over the data on the user interface. It can be changed when specifying the user interface to make it more applicable to the information being displayed or entered. There is a lot done when specifying the data definition. Use the OK control to record the data definition, or the clear control to cancel the data definition. If the data definition is cancelled, the content name will also need to be removed from the content list. The constant field can be used to force a constant value into the data. This can be useful to record fixed values in the database, especially where it is important that a specific value exists. This is a decision made by the developer, and cannot be changed by a user. Constants are rarely used with content data. That has given the first vehicle program all the information it requires, and is where we leave the video presentation. It's a strange way of starting an application, and specifying a program, but that is what has been done. So why should you, or your organization, be interested in this rather radical departure from the traditional application development cycle? To answer this, we should look in a bit more detail at what using the artificial intelligence requires, and what advantages this artificial intelligence can provide. So, we start with the requirements. The specifications required by Enigma are all the products of a good analysis and design for an application. For the user section programs, specify all the data. The user interface content, basically, the data included in an action. The interface design. The navigation between programs. The information, or collections of data, moving to, or from, the database program. The business rules. For the database section, specify the data to be recorded, the information with which the database program is to work, the transactions, basically, the information sent to, or received from, the database. The database tables, primary keys and interconnections. Specifying the requirements is no more than documenting a good analysis and design for a new application. As we saw earlier, the user program is only concerned with sending or receiving information. The information is converted into data for use by the database program. Protection of intellectual property is important, and you may have noticed in the video that there are patents applicable within the Enigma software. The structure of an Enigma-created application is patented in the USA and Australia. This was described with the very generalized schematic. The design of the database section generator is patented in Australia, and is waiting for approval in the USA. This design is not covered in this presentation. So now to some advantages. First, those from the user section. The application is created using the documentation, so the documentation is always up to date. Documenting the analysis and design has to be done, which has no extra cost. In fact, you will make considerable savings. The documentation does not have to be interpreted by a programmer. Less mistakes. Data formatting and editing is consistent across the application. The programs are generated using bug-free, well-tested code. Testing is reduced to checking the user program operation, and end-to-end testing of the navigation. The client can see what is intended early in the development cycle. And finally, more than 99% of the user program code can be generated. So, what about the database section? By having a database section, the database design is simplified. The tables have to conform to third normal form principles. Interconnections between tables are specified by use of the same data name in each table. This makes them very obvious. Primary key definition has to be done for every table, no other constraints are applied. And finally, 100% of the database section code is generated using the defined Enigma structure also provides better database security. Many small black box, single function, user section programs, well suited to internet operation. Small programs load faster, and small information transmission is done faster. Enforced separation of data from information. Application consistency due to generated formatting and editing. And lastly, two very important advantages. Any alterations to the user section programs are totally transparent to the database section, unless new information is required. And any alterations to the database content and/or structure are easily implemented and are totally transparent to the user section. So to finish, some advantages from using the Enigma implementation. Better resource utilization, small teams each creating a part of a bigger application. Time savings, potentially one user program per man-hour, average. Better database security, security that comes from the design, not from yet another layer of software. Maintenance savings, changes can be made without affecting any programs other than those being changed, no inadvertent errors. So that is briefly how artificial intelligence was harnessed for software creation, and what using artificial intelligence can achieve. It should be no surprise that it is a complete departure from the usual application development path, and this is not the be-all and end-all of artificial intelligence software creation. This is a beginning. Other applications will be developed that expand the use of artificial intelligence beyond Enigma's abilities. There is a saying, if it's too good to be true, then it probably isn't true. Using artificial intelligence for software creation is one case where the saying is wrong. I started this part of the presentation posing a question: why should you be interested in Enigma? The advantages when summarized boil down to saving time, saving resources, better security, simpler application maintenance. I will end with another question. One that you will have to answer. This presentation is available on the Parametric Systems website, as is the paper from which this diagram has been extracted. This is a generalized design for an Enigma-developed application. It shows application security by design.